Hey guys, welcome back to session 26 of Java Full Stack Made Easy. Previous session we were discussing about the sets and we have already discussed about a hash set and a tree set. The last of the set implementation we will be talking about here, that is going to be a linked hash set. So let's go back to what we discussed in the previous session. First, let's see the hierarchy again. So we have discussed a hash set and we have discussed a tree set, right? So tree set is the implementation of a sorted set. We have already seen that the elements are sorted by default itself. So in this entire collection hierarchy, there are only two classes which are sorted by default. So this can again be one of a interview question. That is, which of the two classes are sorted by default in a collection? So two classes that are sorted by default in a collection is tree set and a tree map. So wherever you see tree, consider that it is sorted, because internally the tree set is an implementation of a tree map itself. Tree set is an implementation of hash map, sorry, not tree map. It's an implementation of hash map. So tree set is from tree map itself. That's why it is sorted. So internally this is how it works. So tree set is created on basis of tree map. Similarly, hash set is created based on the hash map. So we will see what hash map is, what tree map is, and all that in our later sessions. So let's focus on this thing first, that is sets. So we have already discussed about a hash set and a tree set. Let's talk about a linked hash set, and we will compare all of them and see what differences they provide and when to use what. So now in my previous example, the last example I took was a player hash set, and then I converted that hash set into a tree set so that I wanted an sorted players. Okay, so for sorted set, if you want, you have to always go for a tree set. So let me now just go ahead and remove this sorting, and also I'll just say players, iterate over the players and just print me the players. That's what I want. Players. Okay, so let's go ahead and change. Instead of having a hash set, let's take a linked hash set. Fine. So I'm now adding all the elements to a linked hash set, and you see that I don't have any sorting at all. So there's no tree map, nothing, so no sorting at all. So I've not added any sorting concept here. So let's save it and see how linked hash set differs from a hash set. How does it differ from a tree set? The difference is simple. Tree set is sorted and linked hash set is not sorted. So let's save it and compare these with a hash set. Let's run this and see the difference. So now when I'm running this application, now you notice that while adding the players, I've added player 5, 4, 3, 2 and 1. Okay, so it has actually maintained the order in which I have added the elements. You can see that here 5 is Zahir, 4 is ABD, 3 is Bumrah, 2 is Rohit and Virat, right? So you can see that Zahir, ABD, Bumrah, Rohit and Virat. So our linked hash set has actually maintained the order of insertion. The elements that I have added to the linked hash set, in whichever order I have added the element, the same order is maintained. So in case if you want a set, that means if you want elements to be unique and you want to maintain the insertion order, at that time you will be using a linked hash set. So let me copy this and put it into the repository. It is as simple as that. So this is my session 26, day 26. So let's create a new repository as day 26. Day 26, demo 1, linked hash set. Alright, so in the previous example itself I have shown you how do you, in case if you want the sorting to be implemented, go for the tree set. If you want to maintain the order of insertion, then you can go for a linked hash set. If you just want unique elements, at that time go for a hash set. Okay, one more important question that might be asked in an interview to you is that how many null elements are allowed in a set, right? So whether it is a hash set or a linked hash set or a tree set, the number of null elements allowed differs. How does it differ? Let's now understand that. So what I will do is I'll make it simple. Now that it is a linked hash set, I would like to try and add a null element into it and see the result. Okay, so players dot add, I'm adding a null element into it. So I save it and I try to run this. So it has allowed me to add a null element into it. So you can see that 5 players are added and a null element is added. Now I'll try to add one more null element into it and see what happens. I save it and now I run this, and now you notice that there is only one null element allowed, because again 2 null elements sets are unique, right? So it does not allow 2 null values to you. So which set is allowing only one null value to us? Maximum null element allowed is 1 in a linked hash set. Okay, so this is linked hash set. Linked hash set, 1 null allowed. Okay, similarly I'll just change it to a hash set rather than a linked hash set. So here also I'm trying to add 2 null values. Let's check whether it allows the null values or not and how many it allows. So 1 null value is added, no other null elements are present. That means even the hash set allows just 1 null value. Now lastly, about the tree set, let's see what a tree set provides us, whether the tree set allows us to add a null value or not. So tree set, so this can be a very important interview question. First of all, when I run this, obviously it is going to give me a class cast exception because I'm using a tree set on a user defined object. So because it's a user defined object, it cannot sort it by default on its own, right? So what we have to do is we have to provide in a comparator for it, right? Because it cannot sort the elements based on the natural ordering, right? So I will give a new, what was it, name, player name sort, right? Player name sort. So I want to sort it based on the player name. Save. My requirement is only about checking whether it allows a null value or not. Okay, let it sort on anything. So let's run this and see. The moment I run it, now it throws me a null pointer exception, cannot invoke player dot get name because 0 1, that is object 1 is null, right? So whichever comparison you are doing, be it a comparable or a comparator, at that time tree set is sorted by default, right? So sorting has to be given, must be sorted. So when you are talking about a set must be sorted, obviously it should not allow a null value. So tree sets does not allow null values. It throws a null pointer exception if you try to insert a null element into it. Okay, so this gives us a null pointer exception. Tree set, no null values allowed. If a null is given, throws null pointer exception. Fine. So this is how it works. So let me copy everything and put it into the repository demo2 null values in a set. So the conclusion is what? Hash set allows one null value, linked hash set allows one null value, tree set does not allow a null value. Now you might ask, like, what set has to be used at what situation, right? When to use what? So what is the conclusion is that if you want uh, unique elements but you don't worry about the order of insertion, you go for a hash set. If you're concerned about the order of insertion, that means if you want to maintain the order of insertion, go for a linked hash set. And if you want sorting, that means if you want sorted elements, you use a tree set. Now once again you might say, I am least bothered about maintaining the insertion order or not. I'm least bothered about it and I don't want sorting. So in that case, what should be used, right? You don't want to perform. See, if a scenario arises something like this, you're not bothered about whether the elements are maintaining the order in which the elements are added or not, and you don't even worry about sorting it. So in that case, whether you should go for a linked hash set or a set will be your question, right? So the conclusion for that, the solution for that is that you go for a hash set. Now you might ask, why should I go for a hash set? Why not a linked hash set, right? So the reason for that is the performance. So performance when it comes to hash set, it is faster comparing to a linked hash set, because in a linked hash set we need to maintain the insertion order. It takes some time, so it hits the performance. So if you are least bothered about the elements, order of elements, order of insertion of elements, you better go for a hash set. So hash set, when you want unique elements, go for a hash set because the performance is good. You want unique elements but you want to maintain the order of insertion, go for a linked hash set. You want to sort the unique elements, go for a tree set. So hope the concept about the sets is clear to you. You can directly, one more point into the set that I am using, players. So you can add, remove everything from here as well. So whether it is a list or a set, you can do that. In one of the example, what I showed you was a iterator and the remove method from an iterator, right? So that was in a list. So that was to show you the difference between an iterator, which is editable, whereas enumeration, which was read only. Okay, so and again sorting and everything is same because we have already seen how comparator and comparable works in Java. So let me I think I have already added this null example into the repository. So here once again linked hash set is created in demo 1. So we are done with the concept of sets. In the next session we will see how can we make use of maps, okay, which contains the key and the value pair. Actually I thought of finishing off this linked hash set in the previous session itself, but because I had some emergency, so I left the session in between. So it is just a continuation of the previous session itself, because I am splitting this into the second session. That's why I have named it as session 26. Hardly some 2 demos, and we have compared all of this. So what you can do is, as usual, we go to Google and then we type in what hash set versus linked hash set versus tree set. So you will see all the differences. The major difference I have already spoke about, that is how many null elements are allowed, and also the behavior of each one of them, that is hash set and linked hash set and the tree set, because tree set sorted one, hash set ordered, and linked hash set is ordered, whereas hash set neither ordered nor sorted. Then I have also spoken about the concept of performance when it comes to all 3 of them. So if you rate best performance in hash set, in sets, it is hash set. Second best is linked hash set. The third one is tree set, because the elements has to be sorted. So addition and removal and all takes a lot of time, because once you remove or add an element into a tree set, then again it has to rearrange it according to what? According to the comparator that you have provided. So that's how things works. So hope you are enjoying the concept of collections. See you in the next video. Thank you.